Right, so this video covers question number 8, paper 1 of 2015. So if we have a look at the question, it says we've got to do this through first principles, and then we've got to determine some derivatives. Okay, so this is a standard derivative question, standard first principles, and there's not much complicated. So we're going to start with 8.1, and we're going to say that they want to do 8.1. They want to look at f of x equals x squared minus 3x through first principles. So it's very important that when you do first principles, you do all the layout correctly. And if you want to have a proper quick overview of for derivatives using first principles, please see my video on first principles. I'll provide a link in the description. Well, it's the video on calculus. It covers the basics, but I'll go through it again. And it's a 5-mark question, so it is a fair amount of things. It's what, 5 marks out of 150, so it is quite a bit percentage wise. And if I start, I say, well, we want to do it through first principles, so let's have f of x plus h, because we know that we must have an x plus h. So everywhere you see an x, you plug in x plus h. So we have x plus h squared minus 3x plus h. Now, as I mentioned in the calculus video, I wouldn't highly recommend against plugging that straight into your first principles formula, because it just becomes a mess. So work it out first, as I'm going to do now, and we see this actually works out quite nicely. X squared x squared plus 2xh plus h squared. Right, so you just multiply this first bracket out, however many steps you want, minus 3x minus 3h. Now we say, well, the derivative f dash of x is equal to the limit as h tends to 0, and write this thing out. You get a mark for it. F of x plus h minus f of x divided by h. So you actually get a mark for writing that out. So don't forget that. We then say that it says the limit as h tends to 0. Obviously you do not forget the limit as h tends to 0, or you'll lose all your marks. And you substitute your f of x plus h. But we know what f of x plus h is. That's this thing. We've just worked it out. So we literally substitute it in, put brackets. It's x squared plus 2xh plus h squared minus 3x minus 3h minus f of x. Keep your brackets, always put brackets, x squared minus 3x. And you'll notice how much space we saved by simply working it out. By working it out beforehand. If you had to do that all in this, it just becomes a mess. It's horrible. It's just not nice. So we're almost done. We can see that all the x's that don't have h's, anything that doesn't have an h, cancels. That, if you times it in, becomes a negative x, and that cancels with that x. That negative 3x times a negative becomes a positive 3x. Positive 3x minus 3x becomes 0. So now we are just left with h's in the top. So we can say, well, that gives us the limit as h tends to 0 of, I'm just going to write it out again, 2xh plus h squared minus 3h divided by h. Now, because we only have h's left, the limit as h tends to 0, we still have a problem with this because we can't divide by 0. So we've got to get rid of that. And we can do that by taking h out as a common factor. 2x plus h squared minus 3 divided by h. And we can take them out as a common factor because the only thing we have left is terms with h's. Those two then cancel, and because we no longer have a divide by 0, we can simply say the limit as h tends to 0 of 2x plus h squared minus 3. And because there's no divide by 0, we can actually substitute a 0 into all our h's, and that gives us 2x plus 0 squared minus 3, and just for completion's sake, that gives us 2x minus 3. And you can drop this limit, this sign, once you no longer have this h at the bottom anymore, as I did in this. And if you use the so-called quick method, we can see that the original equation, which was x squared minus 3x, x squared minus 3x, it simply becomes 2x minus 3. Once again, if you don't understand that, please go see my calculus video. And it's exactly the same as the one we derived from first principles, which hopefully it is, otherwise you've done something wrong. 8.2, it's a standard derivative. Now, you only use first principles if they explicitly ask you for first principles. And in this case, they're saying just derive or determine. So 8.2.1, we've got the equation dy dx. If y is equal to x squared minus 1 over x squared squared. So they've given us this thing. All this dy dx simply says take the derivative of y with respect to x. So all it's saying effectively is just take the derivative of y. I don't know why it's not erasing. So it's just saying take the derivative of y. So don't get confused by that symbol. It's just saying take the derivative of y. Now we look at y and we say, well, y is a bit nasty. We can't derive this with that square. So how are we going to go about doing this? For those of you who know what the chain rule is, by all means, this becomes a very easy thing to derive, but most of the metrics don't. So how do we do this? Well, what I would recommend is to actually multiply it out. And not recommend, I would say always multiply this out unless you know the chain rule, which you probably don't. So 1 over x squared. So you know that you can only derive if you have a thing that looks like this, ax to the power of n. If you don't have a thing that looks like that, you can't derive it. So that means that that is fine, this one's fine, this one's fine, that one's fine, that one's fine on their own, but they're not on their own. They have, it's inside a square. So we have to get rid of these, so we have to get single terms. So let's multiply it out. Take that one times that one, and what do we get? Well, we get x to the power of 4. We take that one times that one, and that works out quite nicely because it's x squared, so minus x squared over x squared, so that just goes to 1. We take this one times that one, and it's the same thing. It's just minus x squared over x squared, which cancel out and becomes 1. And then we've got this one times that one, which is negative times negative is a positive, 1 over x to the power of 4. So we simplify this and we see x squared minus 2, the ones come together, plus 1 over x to the power of 4. Now we have separate terms. Everybody's happy. That wasn't very difficult to do. But we still don't like this fraction. This fraction is not pretty. How do we solve that? Well, we know that 1 over x to the power of 4 is the same as saying x to the power of negative 4. So we can write that as x to the power of negative 4. So we have x, sorry, this isn't x squared. This is x to the power of 4. X 4 minus 2 plus x to the power of negative 4. And that is exactly how we want it. So we can go about deriving that. We derive that, and it simply derives to 4x to the power of 3. That 2 disappears, minus 4x, and here, for this top one, we said 4x, 4 minus 1. But this one, we're going to have to say negative 4x, negative 4 minus 1. So it actually becomes negative 5. And they don't like it written like that. You must always have a positive exponential or positive exponent. So we end up with 4x to the 3 minus 4 divided by x to the power of 5. And that's what we're left with. Okay, so I would always recommend writing it with a positive exponent, but yeah, it's up to you, but I would recommend it. Okay, 8.2.2. 8.2.2 gives us dx of x to the power of 3 minus 1 divided by x minus 1. And then all that this one says, much like the dy over dx, and what we do is we simply say, well, it says take the derivative with respect to x. So all this sign means, as I mentioned in my calculus video, all this sign means is take the derivative of this function. So we're going to do that. But once again, we can't take the derivative unless they're individual terms. Well, the good thing about this is we've got perfect cubes. Right? There's a perfect cube, and we're going to cancel out something there. So let's simplify x to the power of 3 minus 1 into its individual form. So we know that x to the power of 3 minus 1, we know we are going to get x minus 1 because we have to cancel with it over here. So x minus 1 times what gives us x to the power of 3 minus 1. Well, the good news is x times x squared gives us x cubed, and 1 times minus 1, or minus 1 times 1, gives us minus 1. So we've got the first few pieces. And then this guy here, we're just going to have it as an x. Now you can solve that however you want. You can go about solving it however you want. I suggest if you do have an issue with that, just either see one of my other videos where I discuss basic algebra, or we can I don't particularly want to go through it right now, so either send me a message, or you can go through one of the other videos where I actively discuss how to do that. But you just break that up, and the nice part is the first piece is that you're going to have to get that because it has to cancel, so that's your first piece. Then you simply look at your first one, which is x times what gives us x cubed, so x times that. So you can just effectively divide it. X cubed divided by x cubed divided by x equals x squared, and that's what goes there. Then you say, okay, minus 1 divided by minus 1, right, there and there, gives us that one. Obviously, that's 1, so we get plus 1 there. And then you say, well, how the hell do we get that middle piece? The good news is, what we can do is we can say, no, I'm ending up explaining the whole thing again, so might as well finish. If we say we didn't know what that middle term was, and we say that one times that one, and we get x cubed, and that one times that one, and we get plus x squared, and that one times that one is minus x squared, and that one times that one is minus 1. Okay, and we see, well, actually, that works. So, sorry, not x squared, x. Sorry, that one times that one, this one times that one is x, not x squared. My apologies. So we get this thing, and we see, well, we've got our x cubed and we've got our minus 1, but we've got these nasty terms in the middle. And how do we get rid of those terms? So we say to ourselves, what do we have to multiply in here? Something's missing in here that gets rid of those terms. So you can look at either the 1 or the x. I'm going to look at the x because it just makes more sense. And we say x multiplied by what gives us the opposite of this. So in other words, negative x squared, right? Negative x squared, we want the opposite of that to come out. So we've got to look at the opposite. What is the opposite of negative x squared? Positive x squared. Positive x squared divided by x, which is this one, equals x. And that is what goes in there. Okay, so we got to look at the opposite. So let me show you how that works. If we multiply it out, if we put an x in here, we found that out because remember I said we need to fill in the opposite, so we put in a plus x. If you now multiply that out, that times that is x cubed, that times that is plus x squared, that times that is plus x. That times that is minus x squared, that times that is minus x, and that times that is minus 1. That x cancels there, that cancels there, and we're left with x cubed minus 1. It's that easy. Right, so now we know exactly what we've got. Now I'm just going to take this off. We don't really need that, but now that we figured that out, we can say, well, this one obviously divided by x minus 1, that one's also divided by x minus 1. And once again, I knew this was my first term because I know we have to cancel with the bottom term. And we're going to cancel with the bottom term. That one cancels with that one. And then we are left with a function that says x squared plus x plus 1. That is our new function. And can we derive that? Of course we can derive that. So we're saying take the derivative of that new simplified function, and that is equal to 2x plus 1. Now if you look at the memo says you could use something called the quotient rule. Once again, you guys haven't learned that. That's maths or advanced maths. So don't worry about that. It's the same as the chain rule. Don't stress about that. I would leave it completely. Okay, and that is question number 8 done.